Hi guys, we're going to move on to the last section here of Chapter 3, and it's called Rewriting Equations and Formulas. We're going to use common formulas. Some of them are going to look familiar to you. You've seen them before, and maybe some of them look new to you. And we're going to rewrite equations and formulas by solving for one variable in terms of the other. That means you're going to get one variable, chosen variable, on one side of the equal sign, and on the other side of the equal sign may not be a number, but an expression with other variables in it. That's what in terms of the others mean. As always, this video is on Ms. Jackson Math Teacher YouTube channel. Okay, let's start out with vocab. What is a formula? A formula is first and foremost an equation. It has an equal sign in it. And that equation represents two or more quantities. And almost always those quantities are represented by variables. And usually these formulas also represent some real world situation. And we use these formulas because these particular situations come up time and time again. Okay, so let's start out with some of the common formulas. First one is distance, rate, time. And the distance is the length or how long, how many miles, etc. that you traveled. And the rate is another word for speed. That's why I have a speedometer here shown. And you multiply that by the time that you've been traveling. So distance, here, d equals rate times time. Now this only works if the rate is constant, and I'm going to write that down. That means unchanging. It can't be going up, going down, or varying. The rate has to be consistent or constant. The next formula we're going to look at is called simple interest, and the simple interest formula is I for interest equals the principal times the rate times the time. Now in this case we have rate and time in the same formula, or sorry, a different formula, but the same variables. Time in this case means usually in years. Okay, so usually this case here, time is how many years you've borrowed or invested money. Interest is how much money you're earning on or paying on that money. So in other words, if you're borrowing money to pay for a car, for instance, you're going to have to pay interest on borrowing that money back to the bank. However, if you put your money in the bank, you've invested it in the bank, they're going to pay you interest in exchange for using your money. In other words, your money's not sitting in a box or a safe somewhere. They're actually using your money that you put in the bank, and in exchange they're paying you a small interest fee. Okay, principal, P, is the starting amount of money. So if you're borrowing money, say if you want to buy a car for $20,000, that would be the principal. You're borrowing that much money. If you are putting in $10,000 into a bank account, that's your principal. Over here on distance, rate, and time, this rate was your speed that you're traveling. Here, this rate is the interest rate. So it's usually in the form of a decimal. Today in the United States, the interest rates are still very low. They've been very low for many years now. But they do vary. So over time, in an inflationary period, the interest rate may increase. So you would just multiply that principal amount of money times that interest rate times the time invested, and that will give you the interest. Okay, since we're talking about money, let's talk about profit here. Profit or loss. They kind of are two sides to the same coin. So profit means you gain money, and loss is you're losing money. And the formula is the same. So it's profit equals the income minus expenses. And income, another word for income you may see in some word problems, is sales. And another word for expenses could be costs. Okay, so almost nearly every business is in business to make a profit. That means that the income or sales that they take in far exceeds the expenses for whatever their product or service is, and therefore When we subtract those lower expenses from a big income, you get a nice positive number, and that will give you profit. However, if you're a business who has, unfortunately, too many expenses and too low of income, then that business is going to experience a loss. And no business is able to sustain a loss for very long. So generally, businesses of that sort will go out of business pretty quickly. Okay, let's take a look at some geometry problems. The area of a rectangle. The area of a rectangle is kind of the inside space of that rectangle. And if you remember, a rectangle has 4 sides. It's called a quadrilateral, and the opposite sides are congruent. That's why I'm showing these slash marks. I'm showing that the opposite sides are of equal length, and the area of a rectangle is that length times width. Sometimes you may see the length called the base and the width called the height, and it doesn't matter. It would be the same formula, just with different variables. The area in that case would be the base times the height. Now, the area of a square is very similar. The area of a square is also the length times the height, the length times the width, or the base times the height. But in this case, a square has 4 equal side lengths. So if we write down the area equals the length times the width, and in this case I've labeled, let me erase that here, I've labeled the length of all 4 sides to be s, then we would have s times s, and we could simplify that a little bit using an exponent. S times s would be s squared. So that's where the phrase square comes from, is actually from the area inside of a square. And if we look at the area of a triangle, the area of a triangle is area equals 1/2 times the base times the height. In this case, the base is the bottom here of the triangle, this whole length. I should show that. The base here is the whole length of the bottom here. And the height is derived from starting from one point of the outside of the triangle. It's called a vertex. If we draw a straight line from that vertex to the opposite side, and we draw that at a 90-degree angle, or that's also called perpendicular line, then that would be the height. So you can see from a number of these examples that these common formulas are all made up of variables. Each one of them has multiple letters in them. They're relating multiple quantities together, and we can solve these for any particular value within the formula. All right, let's look at some more formulas for circles now. The area of a circle, in this case, this little r, I'm going to make it bigger. There's an r here. That r stands for the radius. And the radius starts at the center and goes to the outside. You could go to anywhere you want here, and the radius is going to be the same in that circle. And the area formula for a circle is pi, which is a constant, an irrational number, times the square of the radius, pi r squared. And there is pi, actually maybe I'll write this, pi is approximately, I'm going to show that with these squiggly lines, 3.14. However, it goes on forever, as you know, an irrational number, and I prefer it if you use the pi button on the calculator rather than 3.14. All right, the circumference of the circle is the outside. It's almost like the perimeter of a polygon. And their circumference formula is similar. C equals 2 pi r. Now, a lot of people get these two formulas confused with each other. The good news is they're on the reference sheet. So you can always look at that reference sheet when working with the area or circumference of a circle. And I should probably also just draw in again the radius here. All right, let's look at some volume. Volume is something that we express the inside space, if you will, of three-dimensional objects. And here is, it looks like a box. and it is, a box shape is called a rectangular prism. And the volume of a rectangular prism, V for volume, is the length times the width times the height. So volume V, and L again is length, and the width again is, W is the width, and now we have the height of the box. Okay, let's look over here now, switching gears a little bit to the XY coordinate plane. We haven't done a lot yet this year on that, but we're going to move to that next chapter. And this may look familiar to a lot of you. A line, this red line here, can be represented by y equals mx plus b. Now y is the dependent variable. X is the independent variable. I'm going to put y. X is the independent. And m stands for slope. And it's m because we think of slope as a mountain. And b is the y-intercept. That's where the line crosses or intersects here the y-axis. Slope is how steep or how flat that line is. And we're going to be doing a lot of work here with the equations of lines. All right, let's take a look at some examples on how we can use the formulas. Let's start out with the distance equals rate times time. Example 1, how many miles have you traveled if your speed is 60 miles per hour? MPH is called an acronym, and it stands for miles per hour. I forgot my parentheses over here. If you've been traveling for 5 hours, well, the first thing you would always do is write down the formula. Distance equals rate times time. Now, this formula is not on the reference sheet, so this is something that you have to know and memorize. And I like to think of just a quick little memory jogger. I think of the word dirt because it kind of sets it up. If you replace that I with an equal sign, then you have distance equals rate times time. So how many miles have you traveled? That's asking you for the distance. How many miles have you traveled? So we don't know what the distance is. So we're going to solve for the distance. But we do know that the rate is 60 miles per hour. And I'm going to write that this way, 60 miles per 1 hour. And we've traveled for 5 hours. So I'm going to write that T as 5 hours. Notice I'm not just writing down numbers, I'm writing down the units. Well, the effect of this, it's almost like I have fractions I'm multiplying. If I have hours here in the numerator and hours down here at the denominator, it's just like if the numbers were canceling out. 1 hour divided by 1 hour, those units cancel. So we only have the units miles left, and that's perfect because we're looking for the distance. So I have 60 times 5, which is 300. So we've traveled 300 miles. And you're going to want to write your problem exactly this way. Please do not just write numbers. Always use units because they help you solve the problem. Okay, let's see what I mean by that. What speed are you traveling? Speed stands for the rate. So this time we're trying to solve the rate for R. If you are traveling, if you've traveled for 45 minutes and you've traveled 5 miles, so the 45 minutes is time, and the 5 miles here is our distance. So again, write down the formula. Distance equals rate times time. We know that our distance we're going to substitute is 5. And we're being asked for the speed, the rate. So we're solving for R, and we've been traveling for 45 minutes. Again, use, and I should have put miles here. All right, so this is 5 equals 45R. We're solving for the rate, the speed, so we go directly to that unknown. Look what's around it, undo it with the inverse operation. So we have multiplication we're undoing with division. I'm going to divide both sides by 45. And the 45 is reduced to 1. And the rate is, I've got 5/45. Well, if I divide the top and the bottom by 5, I would have 1/9. And what did we solve for? We solved for the rate. And the rate is a ratio. So up here we had miles, 5 miles, and down here we had minutes. So we're traveling for every for every 9 minutes, we're traveling 1 mile. So we can change that if we wanted to, or we could leave it this way, 1 mile per 9 minutes. Now, another way to do this problem is to start out with the distance equals rate times time. And instead of substituting numbers right away, let's just rewrite this equation. We want to solve for the rate. That's what we're being asked to solve for. So what's happening here? Go to the unknown, the one that you want to get all by itself. Here is the rate. It's being multiplied by time. How do we undo multiplication? We undo multiplication with division. Anything we do on one side of the equal sign, we got to do exactly the same thing on the other. So the t's reduce out to 1, and rate's all by itself, and we have distance divided by time. So we could start out with this new formula, this rewritten formula, and make our math a little bit easier. Example number 3. Now let's do some geometry problems. The area of a rectangle is 54 square centimeters. Whenever it comes to geometry, I always tell my students, draw a picture. So a rectangle has opposite sides being congruent, and we know that the area here inside equals 54 square centimeters. I'm going to write that there. Now, we're told that the length of the rectangle is 10 centimeters, but we don't know what the width is, and we want to find the width. Right here is saying, what is the width? Start with your formula. The area of a rectangle equals length times width. Now we can substitute our numbers in right away if you wanted to. 54 square centimeters equals 10 centimeters times the width. I'm going to show that with parentheses. Go to the unknown, go directly to the unknown. Look what's around it. It's being multiplied by 10 centimeters. I'm going to undo that multiplication with division. This is a 0. Oh, I don't like it. I'm going to redo it. And 10 divided by 10 is going to be 1. So W is all by itself. Now up here, when we have square centimeters, I'm going to rewrite that. 54 square centimeters is 54 centimeters times centimeters. 2 of them. It's just like a number divided by 10 centimeters. So what happens here is one of these centimeters cancels out. So in the end, we're solving, the units are going to be centimeters for the width. Now 54 divided by 10, I'm going to do that up here. 10 goes into 54 5 times. That's going to be 50, and I have a remainder of 4. So I have 5 and 4 tenths. So the width equals 5 and 4 tenths centimeters, or you can write that as a decimal, 5 and 4 tenths, that being in the tenths position, place value. All right, let's do some more area. Example 4, the area of a triangle is 28 centimeters. Now, that can't possibly be true, so I have an error here in the problem. Square centimeters. Always area is in square centimeters, so please correct that. Draw a picture. I'm just going to draw a sketch of a triangle. I've got my height, I've got my base, and we're told that the area is 28 square centimeters. We got to go to our formula. Area equals 1/2 base times height. The area is, actually, let's rewrite this formula. So we're told that the height here is 4 centimeters, and we're being asked for the base. So let's rewrite this formula, solving for the base. We'll go to the unknown, go directly to the unknown. That base is actually being divided by 2 and multiplied by the height. Let's undo division of 2 by multiplying by 2. And of course over here then that 2 and 2 are going to cancel, so we end up with 2a equals the base times the height. We still want to get that base by itself, and the base is being multiplied by the height, so let's undo multiplication with division. And of course the height divided by itself is going to cancel, so we have the base equals 2 times the area divided by the height. Now let's substitute in. The base equals 2 times 28 square centimeters divided by the height, which is 4 centimeters. What do we have here? Well, let's, instead of multiplying 2 by 28, let's just simplify. 28 divided by 4 is 7. So our base equals 14, and again, square centimeters, I can rewrite it as centimeters times centimeters up here, so we're going to end up with cancel. The base has got to be 14 centimeters. Alright, let's try 3 more examples and then we're done. Example 5. You are planning to sell school calendars to fundraise for the soccer team. Your goal is to make a profit of 500. So let's write that down. Profit of 500. Each calendar, each is a key word here. Each calendar costs you $5 to print. That means those are costs or expenses. And you plan to sell them for $10 each. Again, each. How can we represent that? Let's use number of calendars. Okay, number of calendars that you sell and print. Let's call that X. Okay, so profit equals income minus expenses. Now we want $500 for profit. So I'm going to substitute $500 in here for the profit. Now we have an income or sales. We're going to make $10 of sales for every calendar. So that would be $10 times every calendar that we sell. However, it costs us money to make the calendars, so we have to subtract out our expenses. And for every calendar, that means multiplication, we have to spend $5. So we have 500 equals 10x minus 5x is 5x. I'm solving for the number of calendars here, so I go to the unknown, undo the operations around it, and we have x equals 100. 100 what? Calendars. So what did we just solve for? If we print and sell 100 calendars, then this soccer team would reach their goal of making $500 profit. Now, if we printed less calendars, they're still going to make some profit. If we printed more, you're going to make more profit. So that's how that goes. The more you sell, the more money you're going to make. All right, the area of a circle. Draw a sketch always. The area of a circle is 200 square inches. Sometimes people just write out the word square, so I'm going to try that out too. What is the radius of the circle? So now we're going to solve for the radius. Well, the area, if you look up the formula on the previous page, area of a circle is pi r squared. Let's solve for r. We're trying to get r. Well, we're going to undo the operations around r from the bottom up of PEMDAS. And what we have is we have pi multiplying r. We're at this level. And that square there is an exponent, so that's at this level. So we're going to undo the multiplication first. And we undo multiplication with division. So the pi's cancel over here, so we have area divided by pi equals r squared. And how do we undo a squaring? Well, we studied that back in chapter 2. We undo squaring with square root. So when I take the square root over here, I am going to take the square root of this entire quotient here. So in the end, we have r equals the square root of the area divided by pi. R equals the square root of 200 divided by pi. And if you figure that out with a calculator, that's approximately 64, and the square root of 64 is 8. And those would be 8 inches. So that would be 8 inches we solved for. All right, let's take a look at a line, and then we're done. An example of a line is, an example of an equation of a line is 2y minus 4x equals 12. We want to rewrite that in what's called the slope here, y-intercept form. That means we want to get y all by itself. So let's rewrite the problem. 2y minus 4x equals 12. Well, we're solving for y. What's happening to y? Look at PEMDAS. We've got y being multiplied by 2, and we have a subtraction of 4x. We have to undo those from the bottom up. So we're going to undo that subtraction first with addition. Notice how I offset my adding of 4x over on the right-hand side here. The reason why I did that is because they're not like terms. 12 and 4x cannot be combined. So I'm just going to bring down the 12 and the 4x. Here, they cannot be combined. Then subtract 4x and add 4x is going to cancel, and 2y is going to come down. Now, how do we undo multiplication? We undo multiplication with division, and when I divide over here, I've got to divide the whole thing by 2. So these 2's cancel. 12 divided by 2 is 6, and 4x divided by 2 is 2x. And the final step here to get this into y equals the slope mx plus b form is we're just going to rewrite these here because we want our x term first, and there's no problem with doing that, commutative property of addition. So we could say y equals 2x plus 6. Thanks for listening. Take care.